Your walls aren't the real problem. A modern, energy-efficient window can block more signal than a concrete wall, and almost nobody knows that. That's not a myth, it's real physics. By the end of this, you'll know exactly why signal dies in some rooms and not others, and what actually helps. Here's what actually happens when a signal reaches a wall, and it isn't simply blocked. Some of it reflects right off the surface, the same way light reflects off a window, just because it's crossing into a different material. What actually gets inside decays as it travels, soaked up and turned into a tiny bit of heat. And separately, some of the signal never touches the wall at all. It bends around corners and edges instead, whether that's a doorway or the whole building. 3 different mechanisms, not one big wall. That's also why higher frequencies struggle more indoors, for 2 reasons together, not one. Materials themselves get measurably lossier at higher frequencies, and shorter wavelengths bend around obstacles less easily too. The same wall that barely touches a low-frequency signal soaks up dramatically more of a high one. It's exactly why Wi-Fi's newest, fastest bands, 5 GHz and now 6 GHz, get through walls worse than the original 2.4 GHz did. Some materials barely notice you're there. Lab measurements put plain drywall under a decibel, and dry wood in the low single digits. You'd barely feel it. Concrete is messier. Real building walls with rebar and everything else built in have measured anywhere from the 20s well past 40 decibels. Researchers have even found that the industry's own standard formulas can be off by a lot. Concrete is the one material engineers still argue about. Now here's a genuinely surprising one. Plain glass is actually a low-loss material, only a few decibels, because most of what it does is reflect a little at the surface, not absorb. It should be one of the best materials for signal in the whole house. But a modern energy-efficient window changes everything. Measured losses on coated glass jump to 30, sometimes over 40 decibels. Suddenly, your window is worse than that concrete wall. Here's why. Coat that same glass with a microscopic layer of metal, the coating that reflects heat back into the room. And that thin metal layer does almost all the damage. None of this is one and done either. Every wall or floor between you and the rotor adds its own loss on top of the last one. Which is exactly why the same 3 rooms always lose the fight, usually for a mix of reasons at once, not just one. Bathrooms tend to pack in metal pipework, mirror backing, and denser tiled walls. It's not steam. Humidity barely touches a Wi-Fi signal. Basements sit below grade, behind the thickest, most reinforced concrete in the house, with the earth outside making it worse again. And garages often have a steel door standing between you and the rotor. A continuous sheet of metal is one of the most effective blockers there is. Same physics, 3 different rooms. 2 more things worth knowing. Full bars don't mean a fast connection. Bars measure raw signal power, not congestion or interference, so 5 bars and a terrible connection can happen at the same time. And rotor height matters less because it somehow broadcasts harder, and more, because putting it up high and out in the open simply puts fewer walls and floors directly in its path. One dated call, since apparently that's my job now. Wi-Fi's newest bands keep trading penetration for speed. 5 GHz already gets through less than 2.4, and 6 GHz is worse still. By 2029, expect multi-point mesh systems to ship as the default in new homes, not an add-on, because one rotor in a corner won't keep up. Blame the cat. So, bad luck or physics, it's physics. The walls, the windows, and the water are all doing exactly what the numbers say they will. If you want more of the spectrum truth nobody explains, there's a link below, and I'll be in the CRT.
And that's the quick version. If you want the deeper history behind stuff like this, I've got a whole channel for that. From smoke to signal, links below. See you next time.